Hello everyone and welcome back to our discussion. So we will be discussing on integrable combination. This is again another method of solving a first order, first degree differential equations. Now here are list of common exact differentials. So we know that x dy plus y dx is taken from a differential of a product of xy. Now this one, the next that follows, do we have x dy minus y dx over x squared, So it's a ratio, it's also a differential of a ratio of y over x. And examine the rest of the list, so dalawa. So they can appear in your differential equations, Now, some differential equations contain certain groups of terms which are differentials of non-function like this, as listed. So such group are called integrable combination. Some of the DE may be inexact when they are given, and their integrating factor can only be determined by inspection, So comparing it to the list of common exact differentials. So all of this, you have to familiarize, So ln, the differential of ln of xy, So it's also x dy plus y dx over xy. So if you consider the list of common exact differentials, so only the first and the sixth, are actually separated with positive sign. So ang uban, puros doon ay mga negative. So if you will be considering the simpler form, so kaning nasa first 3. So muna yung mga simple ug barog, including kining 6, So they are written, simpler than the other. Okay, so let's try, to use this but before using this one, so let us try to consider solving a differential equation, in a method, wherein it was previously introduced to us, and atong i-compare with a new method which is by the use of integrable combination. Okay? Now suppose, you are given a DE, and we will be solving this, or we have to examine its exactness by taking the partial derivatives of the coefficient of dx and the dy. So your m, your m is equal to, okay, I distribute my y. Okay, so we have 2xy squared plus y. My n is the coefficient of the dy. Now, solving for the integrating factor, so which means this is inexact. Nakita mo tag integrating factor, Okay. So, but first I have to check for the exactness. Taking the partial derivative of m with respect to y. So, there I obtain, the derivative of y squared is 2y. So, as a whole term, so that is 4xy. Plus, derivative of y with respect to y is 1. Derivative of x with respect to x, the partial derivative of n with respect to x is equal to negative 1. So, subtracting these two partial derivative will give you 4xy plus plus 2. Because we have 1 subtracted with a negative 1. So there's a common factor of 2. So I remove 2 as by factoring. So there I have the factored form of this difference. Now, I write this in factored form because I want to compare that with the coefficient of my given. Okay, so if you divide with x, or divide with n, the expected result is supposed to be a function in x, But dividing with n, But dividing with x, actually, dili kita ka-arrive of function that is purely x. So, case 1 is not applicable under this situation, So, let's try using case 2. Now, I think case 2 is best to use because of the presence of the function 2xy plus 1. So, if this can be the divisor of this difference, okay, let's try. Then we can easily arrive with the expected result which is a function in y, Okay, so the 2xy plus 1 can be removed. This is containing the xy function, So mawagtang, and what is left is a function that is purely y, okay, which is 2 over y. So with this, I can now proceed with the if. My if is equal to the exponential of the negative of the integral of the f of y solved, So we have the exponential. I can put the negative 2 outside, So the negative is coming from the formula, So we have 2 integral of dy over y. So this is minus 2l in y, or exponential of minus 2l in y. To further simplify, there is e and there is ln, So I have to let my coefficient of -2 be taken as a power of y so that we can simplify that being exactly equal to y to a power of minus 2. Okay? Now, after knowing the IF is to be multiplied to the given dA and may be rechecked for its exactness. Okay, so when it's multiplied, so this is the resulting equation. So this is out, so we have 2x, so we have y to power minus 1. This is the product of x and y to power minus 2, the coefficient of dy equal to 0. You may recheck for the exactness, or you can just proceed with your f, and your f is obtained if you integrate partially the first term with respect to the variable x. Now, so we have the integral of 2x plus y to power minus 1 partially imong integrate with x, so we have x squared, and we have a constant of y to power minus 1. The integral of dx is just x. Now, so plus the unknown function in y, because we are treating our y to be a function, or we are treating our y as a constant. No? So the unknown function is part of the constant of integration. So it is a function involving y. No? Now, from the second term, I have to integrate this also partially with y. So my x is constant. So minus x as a constant is placed before the integral sign. So subjected to integration is y to power minus 2. Okay? So the integral, when you increase the power by 1, n plus 1. Okay, so that's the divisor also of n plus 1. So it's minus 1. Minus 2 plus 1 is minus 1. Okay, so this is equivalent to x over y. No? So plus the unknown function involving x. That is the second equation. And then, to arrive with f, or to arrive with our solution, I may consider equation 1. No? So, I have to collect the term like x squared. This is x over y. I'll be looking for a function purely y here, if it exists. But the function in y does not exist in equation 2. That means this is not existing. So, you can have your answer, which is x squared plus x over y equated to f, but f is equal to c, so you can have your answer being equal to this. Or you can remove the denominator y. So by multiplying with y, we have x squared y plus x equal to cy. This is exactly the same as what we did in the previous topic we discussed. No? Now, what is new? The new is by applying the integrable combination. Okay, so this is how to use the integrable combination. No? So, I try to present the first approach, no, because I want you to appreciate, no, what is the advantage of using the integrable combination when it is applicable. No? Okay, so, performing the operations in every term. Okay, so this is the product. When I distribute my y and the dx, and this is my first term containing dx, this is y dx and minus x dy. Okay? Now, you have to regroup the terms in such a way that the coefficient of your dx and dy must contain a function of the same degree. So, obviously, so these two terms are part of a group. Kine, this is a separate term. No? Okay, so this is dx, doon ay coefficient ng xy squared. Okay? Now, let us compare with the list of common exact differentials, no? So, tanaw na to asay mas dool ini. If I have y dx minus x dy, asa mo na aron dire? There is y dx minus x dy. But, it needs a denominator which is y squared. So, I can provide this with y squared in the denominator side by multiplying with 1 over y squared. Correct? So, there is already a y squared here. Now, if you multiply every term with 1 over y squared or divide with y squared, no? So, malibre sa problema ang imuhang dx term, because if this is x, if ever there is a coefficient of your dx here, that coefficient must be purely x to make it integrable. So, by dividing with y squared, no? So, the first term here is actually relieved out of a problem, no? So, dividing with y squared, this is the result. Okay? So, the 2x dx is the term left in the first term. And I form a ratio between y dx minus x dy over y squared, which is actually following case number 3, or the third common exact differential. Now, with this, no, pwede na ka mag-integrate. If this is x and the function associated with the dx is also x, so that's integrable. But if this is paired with another variable y, so dili pa na siya integrable. No? And you have to look for a way on how to arrive with a function which is integrable. This one, it's okay because this is the integral of a differential of a ratio x over y. So just like may integral of a do. Okay? So pareho na siya. So, the integral of my first term is, okay, x squared over 2. So, 2 is eliminated. The integral of du is u. So, that means what is left here is only x over y. And this is equated to the integral of 0, which is c. Okay, now, removing your y, so we have x squared y plus x equal to cy. Now, so compared to the answer ganina and the solution we did, no? So, actually, this will save enough time. Okay? So, makita ni mo unsa mubo ang atong pag-solve, no? Mubo siya pero dako o unsa points ma-earn, no? Bitaw mo ra imong points ma-earn compared to ganina. Okay? So, to familiarize with this kind of approach, no? Let's have another problem. Okay, so if we have x squared y to the fourth power dx plus x cubed y cubed plus 1 dy equal to 0. Okay, so let us perform the operation in every term and we have to regroup later. Okay, so the dx term is in having a coefficient of a degree of 6. No? When it is distributed, the dy term is also containing a degree of 6 na coefficients. That's why we try to group them. There is another term, no? Which cannot be grouped with the other, so pwede rin siya nga siya ang usara, no? Okay, so equated to 0. I notice that there is a common factor between the two terms, no? The common factor is x squared y cubed. So I can remove that one. So x squared y cubed, and we have y dx plus x dy. This follows the first common exact differential. This is a differential maybe of a product of xy, okay? So this is produced, no? Now, if this is a differential of xy, no? If I'm going to consider this equation above, no? This one. So there are actually two options, no? It's either you have to produce x with the same power of 3 with your y. No? But if you have to multiply with x, then the second term, the dy term will be affected because dy will be associated with x and it's no longer integrable if that's the case. That is why you have to divide with y. So dividing with y, so will produce x squared, will produce y squared. So I take the xy term or the xy function to contain the same power of 2. Okay? The dy is now divided by y. So actually there is no problem because it is in agreement with the same function y. Okay, now, so if we have to proceed with integration, integrate each term with respect to, actually we integrate, no? And this is actually following to a form of u squared when this is a du. Okay, so hindi ko may with respect to because this is u squared and that's the du. This is a variable y, so this is a dy or this is your u, that's the du. So this is du over u. Okay? So, I can integrate under a power rule. So, I can increase the exponent by 1. It becomes 3. I can divide it with n plus 1, which is also 3. So, plus. What's the rule? That's L and y. And that's equal to 6. So, if I'm going to remove my denominator, 3, multiply. So, this is now the answer we obtain by integrable combination. Just in case, now, you will be asked, now, because we are actually providing expressions dire to arrive with the exact differential or common exact differential here. You notice, no, that dire, the expression that we multiplied is 1 over y squared. Actually, that is already the IF. So, if you solve for the IF, that's the IF that you solved now previously. Dire, kung sa may itong IF, the only expression we provided is 1 over y. So, the IF is y to power minus 1 or the 1 over y. Okay? Now, let's go with the next problem. This is only for familiarization because we were able to introduce already the idea on how to solve under the integrable combination. Okay, so we distribute, we perform the operation in every term. Okay, so we have x to the fifth power y dx, then y to the fourth power dx. Okay, this one minus xy cubed dy minus, this becomes plus, x to power 6 dy equal to 0. If this is containing a degree of pilaman 6, no? So I'll be looking for a term having a degree of 6, which is the last. So I can group them. Kini, this is in a 4th degree. This is also in 4th degree. So there are 2 groups considered here. Okay, so my first group, so containing a degree of 6, containing a degree of 6, degree of 4 ay kaduha. Na? There's a common factor of x to the 5th power. And there's a common factor of y cubed. Correct? Okay. Now, if this is plus, no? Then, common exact differential, no? 1. So, kani mo unahon ako because this is simpler. No? The simplest all between all the common exact differential. So, I may consider this first, no? So, this is a differential of xy. Kini, I cannot take it directly as a differential of any function because if that's minus, you need denominators. It's either a denominator of unsa? Y comes first. So, it's a denominator of y squared if we follow this one. So, if you have to provide a y squared here, so you have to divide with y squared para this can now contain a denominator of y squared. But take note, when you divide with y squared, all the terms will be affected. So, this is also containing y squared. And take note that this is a differential of xy. So, this is now associated with x to the 5th power with y squared. So, dili na siya integrable later. Okay, so, I have to look for another option. Now, if this is x to the 5th power and this is xy nga function, differential of xy, so x to the 5th power is also a problem to the first term. So, what if I'm going to remove this by dividing with x squared? Is that possible? So, if your divisor is x squared here, dapat the denominator, the numerator will start with a term of x dy minus y dx. But my x dy is a second term here. But it can be a first term if I'm going to consider revisions. Okay, so instead of factoring out only y cube, I have to remove by factoring an expression which is minus y cube. Okay, so this is now, no, the revision. Okay, so x to the 5th power, a differential of a product of xy, I have y cube or a negative y cube. So if the negative is included, then I can make this be my first term, this one, and this is now the negative term. Okay, so if that's the arrangement of my term, then my denominator here, because it is x that comes first, then my denominator must be x squared. Okay, so I can provide the x squared here, and what is left here, it is x cube, and that x cube can also be used as a denominator of your y cube. So instead of dividing only with x squared, I have to include the x to power 5. But I have to subdivide na 1 with x squared will be placed here, the x cube will be placed as a denominator of y cube. Okay, so rearranging, we have a differential of xy minus, so y over x with a common power of 3, the differential of, still, the same form, no? But this is y over x. If there's a coefficient, it should also be y over x function. Okay? So that I can integrate. So this is the integral in a form of a dio. Correct? Kine, this is the integral of u squared and a dio, the integral of 0. Okay? So what is the result when you do the integration? We have xy. Then minus, okay, increase the power, that becomes 4 over 4 equal to c. So xy minus, this can be part of the denominator. So y to the 4th power, 4x to the 4th power equal to c. Okay, so this will look simpler if this denominator is removed by multiplying with the LCD of 4x to the 4th power. This is now the resulting equation. By the way, do not look for 4 times c because 4 times is still an arbitrary constant, so that can be represented with c. Okay? So, for the last, okay, so we have this. So, if I have this one, so I have to distribute, no? Because I need to regroup. Okay, so what is the result when they are distributed? Okay, so, xy dx, is that right? Okay, kana. Diba? This is y to the 4th power dx. This is xy cube. Okay, negative. That is plus x squared dy. So, second degree. So, iyang kagrupo is also in second degree. Notice that they are all containing dx and dy. Na? Kini. This is fourth degree. Okay, so we group them. Okay, and there is a common factor. In the first grouping, we have x, correct? Okay, so this is a differential. This is sum of two terms containing differential, y dx plus x dy. Possibly, it can be the first common exact differential in the list, no? Then plus y cube, y dx minus x dy. Again, if y comes first, then I need a denominator of y squared. This is now written in an exact differential, so I may rewrite. Okay, so like that. No? So plus. Okay, so actually the revision considered here is to write my x, no? Actually pwede, no? Pero actually mahimo ra gud tog dinhi mo i-revise, murag wa gihapon sa advantage, okay? So it is being revised as this, same as in the previous, okay? So by removing a negative, so y comes first, no? Okay, so karon if y comes first ganina, so karon when the negative is included in factoring, so pwede na kamo sugod with x dy. Okay? Now this needs a denominator of x squared. There is x here, pero if you divide with x squared, what will happen? So mugawas pa siya nga dunay x gihapon re, 1 over x. Dire, so murag wa masulbad gyud problema. Anyway, so just to provide the x squared na in the denominator, so the resulting equation is this one. X to power minus 1, y to power 3 gihapon. Okay, and this is now a ratio of x dy minus y dx over x squared. Okay, differential of a ratio y over x. Okay, basta x minus denominator side. Okay, so this is, so these are all xy. This is xy. So I'll be looking for a way wherein I can express this to contain a coefficient of xy. So with this, y over x maybe, no? Now, I'm certain that the IF needed will all be containing xy. But I do not know what would be the exact exponent to be used. Okay? So, I must consider an integrating factor of x times y with an unknown power, and ako na siyang i-distribute over this equation or the terms of that equation. Result is, okay na lang, x to power minus 1 from here, and I raise m. So, plus m. Law of exponent is considered y to power m. Okay, differential of xy. This one, y cube. So, there is n. So, y to power 3 plus n. X is a new factor. Okay, so x to power m. How to arrive with the value of m and n? Okay, so ito yung yan. So, to solve for the value of m and n, so I have to examine the relationships of power. No? Okay, pananglit ingini. From the first coefficient, I have a product of xy. So, if ever there is a power of x and y, the exponent must be numerically equal. Okay, so that means minus 1 plus m must be equal to the power of your y, which is n. Or I can rearrange a minus n equal to 1 as my first equation out from these relationships of powers. Now, in the second term, I need to have a ratio of y over x. And both will also contain the same power. In order to bring your x down, so if the value here must be equal to m, your m must be a negative so that it can be placed in the denominator of y. So, 3 plus n must be equal to m, but your m must be a negative value. So, rearranging on the same arrangement, m plus n equal to minus 3. Actually, you can use a system into unknowns in your calculator. Okay, but maklaro raman siguro that if I'm going to add, I can eliminate my n. 2m is equal to minus 2. So, which means your m has a value which is equal to minus 1. So, if m is minus 1, then my n is equal to sa? If that is minus 1 for your m, no? Then, how about your n? Your n will come out to be minus 2. You just substitute here if you like. So, we have minus 1, that's minus 2. That's your value of n. Okay? So, doon na kay value sa m ug n. Okay? So, with that, no? Ato siyang ibutang dire. So, knowing that my m is equal to minus 1, okay? And your n is equal to minus 2. Considering this equation, m is minus 1. So, my x will contain a power which is minus 1, so it's minus 2. Y to contain power of minus 2 because that is your n. That's a differential of xy. Okay, aritas pikas. This is x raised to power m minus 1. How about your y? So that is 3 plus, what's the n value? Minus 2. So this is y to power 1. Okay? Now, that's equivalent to, no? Kung natin tanawon, mao man siya. So, parihog power. Okay, kana opposite in sign, correct? Okay, we can rewrite it as this one. To contain power common which is minus 2, and if this is taken in the denominator side, then I can form a ratio of y over x because they are all containing power of 1. So, both ipasabot na if your function here is xy, that must also be xy, no? To use a power or letter, then the two must bear the same power. If this is y over x, so that must also be y over x to make it integrable, no? So, if there is a coefficient before the differential of a function, that coefficient must be of the same function as this one. Okay? So, integrate under power rule. Okay? First term, adding 1, minus 1. Okay? So, that's minus 1. Adding 1 squared over 2. Okay? So, simplified. So, reciprocal. Okay, so that's equivalent, no? Kana ako lang ang ibutang sa ubos associated with x squared. That's equated to c, and to simplify this, no, I can make this positive terms by multiplying with minus 2. They are the denominators, no? So, this is the LCD. Okay? So, when that is distributed to x is left, this is plus because that is minus. So, 2 is eliminated. So, you have y cubed, correct? And that is minus 2 times c. But that is still c, x squared y. And this is now your answer. So, that's how to solve a DE using the integrable combination. So, ang imuan ng buhaton is only to familiarize, no? So, observe how your equation looks like, no? Or what are the common exact differential that would be present in your differential equation. So, apply that, no? So, i-compare nimo with the list of common exact differential. Okay, so thank you and goodbye for now. So, until the next tutorial video. So, salamat.